70-740 Lesson 10, Configuring Hyper-V Networking. This will be the last of the 4 lessons where we are covering Hyper-V. Now, while we're going to continue using Hyper-V, these are the last ones that are strictly focused on how we use Hyper-V. And in Lesson 10, we're going to cover all of the various ways that we can configure our networking. So let's get into our lesson. What is Hyper-V networking? Well, the Hyper-V virtualization provides virtual networks for the virtual machines to communicate with other virtual machines. And it allows those virtual machines to communicate with the physical network infrastructure. Just like a physical network, these virtual devices connect to virtual switches, which can provide security, isolation, and service levels. So our virtualized switches, our Hyper-V virtual switching, it's a software-based layer 2 network system, and it can be managed with Hyper-V Manager. And if you remember back from your Network Plus studies, at what layer does an Ethernet switch reside? Well, for the most part, they're layer 2. MAC addresses are used to associate ports on those switches, right? Remember the CAM tables? It's a layer 2 device. It switches traffic by MAC address. Remember layer 3, where our routers reside, works with IP. When we build out a network of physical computers, we have to have at least one network adapter in each one of those, and it gets a physical cable and it plugs into a hardware switch. Well, the same's true when we're building our virtualized environment. We have to have virtualized switches that emulate that physical switch, and we have virtual adapters that emulate the physical adapter in each computer. We can add multiple adapters to our virtual machines as well. And we'll take a look at how we can use that to create resiliency and increase throughput later on in our lesson. When we build one of our virtual machines, it's recommended that we use standard network adapters. Now, in previous versions of Hyper-V, these were called synthetic network adapters. They can utilize the VM bus, and that VM bus lets it be faster than the legacy network adapters. Remember, legacy network adapters are only available in Gen 1 machines. The standard network adapters are available in both Gen 1 and Gen 2. They utilize a driver that's part of the integration services. Now, those legacy network adapters, in previous Hyper-Vs, we called that an emulated network adapter. It emulated the Intel 21140 based fast PCI network adapter. So remember, what's the maximum speed of a fast Ethernet adapter? 100 megabits per second. So much lower speeds. Our standard network adapters can communicate at 1 gigabyte per second. In fact, if you look at it, let's take a look at a system that's running. I've got one over here, and if we take a look here, let's look at status. What's the speed on that? 10 gigabits per second. That's what our standard network adapters run at in our virtual environment. Much, much faster with the standard network adapters over the legacy adapters. When we're using those standard network adapters, we can expand, and there's advanced features that provide additional options. We can set a static MAC address. By default, our network adapter gets a dynamic address. However, we could set a specific static MAC address. Remember, every network adapter has to have a MAC address. We'll take a look at that later on here too. We can assign a static MAC address that will never change. Now, obviously, if we do that, there can't be any other adapter, whether it's virtual or physical, on the same network that uses that same address, or you're going to have conflicts. We can enable MAC address spoofing. We can enable DHCP guard, which helps protect against rogue DHCP servers. We can enable port mirroring mode, and what that does is it allows us to put a one adapter into what we call promiscuous mode, where it can listen to all the traffic, and the other network adapters can be put into a mode where they broadcast all their traffic, so that one network adapter that's listening can see all that traffic. This is for monitoring. That network adapter, that system with that network adapter that's going to be monitoring all the traffic, we might run a utility such as Wireshark on that. We can do NIC teaming. We'll take a look at the various ways that we can configure NIC teaming. It allows us to add bandwidth together and gives us failover capability, so that if one network adapter fails, we've got another adapter that can continue to provide network communications. Now, our virtual switches. We can't build a network if we don't have a way to connect our systems together. So when we build our virtualized environment, we have to configure some virtualized switches for those virtual machines to be able to communicate with. There's three different ways that you can configure a virtual switch: external, internal, or private. And external is just what it says. It creates a virtual switch that allows that VM to connect to the physical network adapter and then get access to the internet or to whatever network the physical system is connected to. Now, beginning with Windows Server 2016, this was not available previously, you can connect not only to a physical network adapter but to a wireless network adapter. Before Windows Server 2016, the only option you had was to connect to a physical adapter. So if you're working with a Windows 10 machine that has a wireless adapter and you want to be able to do test environments, you can utilize it. An internal virtual switch. It creates a virtual switch that can be used only by the virtual machines that run on that physical computer, and it also allows communication between those virtual machines and the physical computer. That's an internal. And then finally we have the private virtual switch, and it creates think of it as a switch that has no connection to anything but the VMs that are on that switch. So you can create a isolated environment. Here are the steps for creating that. And you simply go into Server Manager, you select Virtual Switch Manager from the right-hand column, you define the name for it, and you define what type of network you want to create. Then, when you create your virtual machines, you select which adapter will connect to which network. For example, here, these three adapters, which we're going to be using for demonstrating NIC teaming, they're all connected to the London network. Well, I could select different networks right here. I could connect it to external. I could connect it to internal. And then, of course, all these other ones, the Pure WAN, London Network, NA WAN, these are all private networks. We can use PowerShell to create our virtual switches using the new -vm switch command. We don't have to do it in the GUI. And here you can see those PowerShell commands to do such. Understand that if you do not use the -switch type parameter, it will create an external switch. It will create a switch that's set to external. Only if you use the -switch type and then a space and either internal or private will you be able to create an internal or private switch. Now, we can optimize our network performance. To do so, make sure that your physical network infrastructure, that physical network infrastructure that's on your physical server, your hypervisor, it's got to be at least 1 gigabyte per second or more. So if you're connected on a wireless network, are you going to have that? Probably not. So you're probably not going to be able to you're not going to be able to optimize network performance if you're using a wireless infrastructure. What are the ways that we can do this? Well, to do this, make sure that you're using your standard network adapters. First off, they're faster, and they can also reduce overhead on your CPU. You could also create VLANs, and that helps isolate your network so you can optimize your traffic. You can use bandwidth management. You can use NIC teaming to provide larger bandwidth. We can also use hardware acceleration to enable our virtual machine queue, or IPsec task offloading, and single root I/O virtualization. And here's a description of those features. The virtual machine queue, the VMQ, it uses hardware packet filtering, and it delivers data directly to the virtual machines from an external network. This reduces your overhead of routing packets from the management operating system to the virtual machine. That IPsec task offloading, well, what it does is it reduces demands on the virtual machine CPU. It uses a dedicated processor on the physical network adapter. And then finally, that single root I/O virtualization, it uses the network adapter to distribute access to its resources among PCI Express hardware functions. Now, this is the way that you would go about using those advanced features. Each network adapter has a plus or a minus beside it. Well, if it's got a plus beside it, you can expand it. For example, if I click there, I can now see the hardware acceleration features. There's our virtual machine queue, our IPsec task offloading. We can also get access to the advanced features, and we're going to talk about these here in just a moment. So actually what I'm going to do is I'm just going to go back to our lesson. Now, MAC address. Remember, every network adapter has to have a unique MAC address. It needs to have something to uniquely identify it on the network. Well, do we worry about MAC addresses if we're routing on the internet? No, that's done by IP. Our physical network adapters, that MAC address is assigned by the manufacturer and it's permanently attached. It's burnt in, we call it, to the adapter's firmware. Now, they've got some wording here that's incorrect, so I want to address that first off. It says the MAC address is a 6-byte hexadecimal value. Well, how many characters, how many hexadecimal characters are in a MAC address? There's 12. Remember, you're learning in Network Plus. Your MAC address is a 12 hexadecimal character value. The first 6 hexadecimal characters are the OUI, the Organizationally Unique Identifier, that specifies the manufacturer. The last 6 hexadecimal characters identify the adapter. All right, this is misworded. First off, a hexadecimal character translates into how many bytes. How many bytes make up a hexadecimal character? Well, what are the possible values for a hexadecimal character? 0 to what? 0 to 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F, right? 0 to 15. Is 0 a number? Absolutely 0 is a number. So there's 16 possible values for a hexadecimal character. We can use 4 bits to create that. Each pair of hexadecimal characters in a MAC address correspond to 1 octet. Why do I mention that? Well, if we come down here, the first 6 hexadecimal characters, that is always in our Hyper-V environment 00155D. That's registered to Microsoft. That identifies this as being a Hyper-V network adapter that's registered to Microsoft. Now, the 4th and 5th set of hexadecimal characters, they're the last 2 octets of the IP address, and they're converted to hexadecimal. So, for example, if we were on a network that was, say, a very common private IP address range, 192.168.1 dot something, and your hypervisor has been assigned dot 1 dot 10. Well, that fourth and fifth sets of hexadecimal characters are going to translate to 1.10. The sixth and final set of hexadecimal characters, it's going to be any possibility. Remember, it's from 00 to FF. That gives 256 possible addresses. It would be the same as if you took the full value of an octet. If you've got 8 bytes, how many possible combinations are there? Well, let's take a look. And I'm going to go ahead and I'm going to switch this to programmer. And if I type in the, let's see, let's say the value of 25. We can see right here in binary that says 0001 1001. What does that translate into hex? 19. So our sixth hexadecimal character set would be 19. That's how that works. If we received the IP address of 192.168.1.10 for our physical adapter, our fourth and fifth sets of hexadecimal characters would translate into 0001 preceded by 0000. So our fourth set would be 000. Our fifth would be 00000001. And our sixth would be, and so on. Understand that that's how that translates it. The first three sets of hexadecimal characters identify the vendor, just like in a regular MAC address. It's Microsoft. It will always be 00155D. The fourth and the fifth sets, I know I'm going over this but I just want you to understand this. They translate to the last two sets of the IP address that are assigned to the server's physical network adapter. But, you know, I always say it's easier to visualize it. Let's take a look here. So the fourth and the fifth come from the IP address of the physical adapter on the hypervisor. Let's go over to over here, into here. Okay, Virtual Switch Manager. Down here's our MAC address range, and you can see here 00155D. That identifies it as being Microsoft, and more specifically, this is going to be what you see for every instance of Hyper-V. And then we have 0161. Let's take a look here. A hexadecimal 61 translate into decimal 97. That's 01 in hex would be 00000001. Decimal 1. All right? What's the MAC address of this computer? Right here, 192.168.1 translates to the 01. 97 decimal is what? If I select decimal and I type in 97, decimal 97 translates to hex 61, and there it is. Comes straight from your physical network adapter. Okay, I think I've ground that into the ground enough. Let's move on. So, what do we take away from that? We can provide 256 unique MAC addresses. Well, what if you're going to build out a Hyper-V network that's going to have more than 256 devices on it? You're going to run out of MAC addresses to assign. If that's the case, then you would need to go into Hyper-V, and you would have to come in, and here, this is all part of your planning phase, right? You want to do this before you start assigning MAC addresses. You know, keep in mind they're dynamic, so things could be okay. but you might want to change this from, say, 61 to 60. That's going to give you an increase. All right. You may have to increase the availability. Now, what's MAC address spoofing? Okay, MAC address spoofing, right? And right here you can see that. On an individual VM, you can select Enable MAC address spoofing. What this does is it changes the MAC address of the network interface. This is something that we can use when we utilize network load balancing. Network load balancing, which we're going to look at later on in our course, it's a form of clustering, and it allows multiple nodes to provide a server application. So in other words, say you have a web server. You could do network load balancing so that that web server gets shared across multiple servers. If a server goes down, the web server itself stays up. Before we do that, we need to enable the spoofing of MAC addresses. Moving on, let's talk about network isolation. Just the same way as if we're using a physical switch or switches, we want a way to be able to isolate certain systems. We might do this for network performance. We might do it for privacy. If we're doing our test environments, we're going to do it to isolate our network environment so it doesn't intrude into our production network. So we'll do that using the internal or private virtual switches. Additionally, we could create a private network, and then as you saw from the example that we're going to use for our NIC teaming, you can have multiple network adapters. Well, they can be connected to multiple networks. So for example, I do have a server, and that server name is NARTR, so it simulates a router. And if you look here, it has 5 network adapters. It's connected to the private London network adapter, the private Hue WAN, the private NA WAN, the private POR WAN, and it also connects to the external switch. So this does not only subnet routing between networks, but it also does NAT routing to allow those first 4 networks to communicate to the outside world. We can isolate our networks. Keep in mind that if we build a local area network, a LAN, it's typically a small physical area. It's our office or a floor. It could be as much as a group of buildings, but that might be hard to manage. But LANs connect multiple hosts. We connect one LAN to another using a router, just what I just illustrated. Routers route by IP. They're layer 3 devices. Well, the bigger and bigger you get your LANs, the more traffic is being broadcast on it. What happens when it gets too much? Well, it can saturate a network. That traffic can saturate the network. So we could simply deploy more and more routers and chop it up and more. Well, that also has problems associated because you've got to add routing protocols, you're adding additional latency because the traffic has to figure out how to get from one place to another. So how can we subdivide our local area network? Well, we can use VLANs. Just the same way as we can implement VLANs on our physical Ethernet switches, we can do it in our virtual switches. They give us higher performance on medium or large LANs because we're chopping up that broadcast traffic. It gives us better organization of devices, which allows us for easier management. And it provides a little layer of security because our devices can be put on their own LANs and isolate their communication to them. Let's talk about NIC teaming. Now, depending on whose technology you're using, you're going to hear NIC teaming have a couple different names. It could be link aggregation. It could be balancing. It could be NIC bonding or Ethernet bonding. A lot of different names for the same thing. In the Hyper-V, in the Microsoft world, we call it NIC teaming. It's a Windows feature, and you can do this not only just in the Hyper-V virtual machines, but on your physical machines as well. It enables you, the administrator, to join multiple network adapters into a single entity so that they look and appear to be a single connection. This can give you a performance enhancement, or it can give you fault tolerance, or both. Our virtual machines, they can take advantage of NIC teaming, but they're limited to teams of only 2. On your physical, your host operating system, you can have teams of up to 64 NICs. To do this, to do NIC teaming, you've got to complete 3 basic tasks. You have to create the NIC team in the Windows Server, the virtualized operating system. In Hyper-V Manager, we've got to have an external virtual switch using the NIC team. And you've got to configure the network adapter in the virtual machine to connect to the virtual switch. Now, our virtualized network adapters, they're already configured to connect to a virtual switch. So we've already accomplished most of this. All we've got to do is go into a virtual machine and configure our NIC teaming. When we do that, we do it one of 2 ways. We can configure our switch. We can configure it in switch independent mode or switch dependent mode. In switch independent mode, each of your network adapters get connected to different switches. So to do that, I would have to take this virtual machine right here, and which is the one, this is the example we're using. And for example, this adapter might stay to the London network, but this would have to have a different network adapter. They would have to be connected to different switches. In switch dependent mode, all the network adapters get connected to the same switch. This allows you to combine their bandwidth. Switch independent mode gives you alternate routes through the network. So this protects against a single switch failure. Switch dependent mode provides for a network adapter failure and combined bandwidth. Well, as you can see here, in independent mode you can choose between 2 configurations. An active-active, so that all your adapters are functional. And this does also give you additional bandwidth. It gives you increased throughput. Now, if one adapter fails in that active-active, all the traffic gets moved to the remaining adapters. You can also define it as active standby. So in that case, one of the adapters stays offline. If the primary adapter fails, it will fail over to the standby adapter. In the active-active mode, an adapter failure will cause a performance reduction. In the active standby, since you're expecting the bandwidth to only be of a certain level, and if it fails over to the standby, the performance is going to remain the same. In switch dependent mode, we choose static teaming. And basically what it does is it balances the traffic between the adapters in the team. Now, you can also opt to use the LACP, which is Link Aggregation Control Protocol. That's only if your equipment supports it. So let's take a look at this. How do we go about doing this? Well, here's our server. And we can see we've got 3 network adapters, and we've got them assigned as DHCP. So we're going to select NIC teaming, and we're going to enable it. Let's create a new team, and we're going to call it Team 1. And we're going to select the first 2. We're going to go to additional properties, and we can see switch independent is grayed out, load balancing is grayed out. We can't change these. We can specify a standby adapter. We can make our Ethernet 2 our standby adapter. You see some settings are not available for servers running a guest. Let's click OK. It's working on it. It's not instantaneous. Sometimes it takes a few moments for it to become active. You can see active, faulted connection pending. Let's see, where do we refresh? I think we refresh here. Refresh all. Let's take a look at our properties. Remember, it was active. There it went. So it's in standby, but it's ready. So we can see we've got one that's available to be added to the group. Let's see if we can modify this. We're going to do that. And let's switch it to 3. Apply. Click OK. It's going to take a little time. We'll view our properties. We're going to see this change, just like we saw Ethernet 2 change. But that's how you configure that. It's just that simple. And there we are. Now, when we come back out here, and we're going to refresh, all we see is Team 1. Let's go ahead and view that. Here's our Team 1. Now, it got an IP address from our DHCP, just like the other ones had. What's on our other ones? Nothing, because they're in the NIC team now. Now we could go in and we could define a static IP address for this server. What is the bandwidth of this? Look at that. It could have 30 gigabits per second. Well, we know that one of those adapters is set as standby, right? So we could have 20. If we take a look back in our teaming, oh, it put them all as active. I thought we had one defined as standby. None. All adapters are active. Okay, so we could specify it. Let's see what happens here. There, it put it in standby. If we refresh, we'll go back into our NIC team. Let's see what if it were changed and reflects. Yes, it did. 20 gigabits per second. So now we've got 2 adapters that are live, one that's in standby in case one of those adapters fails. That's how NIC teaming works. Now, there's another type of NIC teaming that you can do, and it's called SET, Switch Embedded Teaming, or more completely, RDMA with SET, Remote Direct Memory Access with Switch Embedded Teaming. Now, we first touched on RDMA in lesson 3. But what this does, this is an alternative to your NIC teaming. It's a converged network and allows for different types of remember that a converged network allows for different types of communication within a single network, and that can contain storage, video, data, voice communication, right? That's what a converged network is. You can form a converged network by combining SET with RDMA. This allows you to utilize fewer network adapters in your servers. Well, we can use SET to do NIC teaming at the physical hypervisor level, so to speak. It allows you to use a Hyper-V virtual switch to team up to 8 physical network adapters located on the same Hyper-V host or hypervisor. It combines them into one or more software-based virtual network adapters. So this would create a VM switch for our Hyper-V and bond together our physical adapters on the physical system, so that we would have a new virtual switch available in Hyper-V that would already be a NIC team. And these are the ways that you do that. First off, you have to install data center bridging. Then from the PowerShell, you can only do this from PowerShell. You run a new -VM switch, you give it a name, and then you define what of your physical adapters it's going to connect to. And then you use the -enable embedded teaming space $true. Now, we could do that with the single network adapter that's on my system. As you can see right here, you can create a set capable switch with a single team member. And then later on, you could use the add-VM network adapter commandlet to add to it. These are commandlets that you run on the hypervisor, on your physical Hyper-V host. Remember that. This is not done in the VM. In this lesson, we've discussed Hyper-V virtualization and that it provides virtual networks for our virtual machines. And just like our physical network, we have to have virtualized switches, we have to have virtualized network adapters. We went through all the different types of networks that we can configure, and that if we're using those standard network adapters, we want to make sure that our physical network infrastructure is using at least 1 gigabit per second or faster. We can enable our virtual machine queue, IPsec task offloading, the single root I/O. We can do MAC address spoofing. We can increase the MAC address range that's being handled out by a Hyper-V host if we're going to be configuring larger virtualized networks. And then we discussed how that MAC address is created. And we took a look into NIC teaming, which, remember, depending on the technology, whose technology you're using, it's going to be link aggregation, NIC bonding, balancing. Everybody's got different names for the same purpose. And how it can give us increased performance or failover. Make sure you understand also the way that SET can be enabled, and as well the limitations of our virtualized networking. Thank you for reviewing 70-740 lesson 10, and I'll see you in the next lesson or lab.